Okay, let's look at nerve impulse propagation. Remember we said that the voltage is due to the difference across the membrane, and nerve says that it tries to do that. If there's a difference, there'll be a voltage because there'll be movement, correct?
Right.
If there's no difference across the membrane, will there be a voltage? No. So if I were to, let's look at this condition right here. If I were to add positives here, would the voltage go up or go towards zero? Go towards zero. Because when they get equal, what's the voltage? Zero. Now let's keep that in mind here. What is the resting membrane potential by voltage? What is the threshold for the sodium gates? What's the voltage? Negative 55. And you have your positive charges here. Obviously, you have most of your positive charges out here. What is the extracellular electrolyte? Sodium. Let's say, we'll describe how this happens a little bit later, that in this location, sodium is reaching negative 55, which is threshold. Sodium comes in. So here's all your sodium ions. And now because of that, the outsides become depolarized. Based on the laws of diffusion, what is this high concentration of sodium going to do? Diffuse from high to low. If you have more sodium here than you have here, which direction will the sodium diffuse? From here to here, correct? So as you add sodiums here, what happens to the difference across this membrane? Gets less, so voltage goes towards zero, doesn't it? Before it gets to zero, what numbers are going to come across? Threshold. So now that reaches threshold, this sodium starts flowing in, right? And it starts diffusing. As it diffuses over here, what happens to voltage in this region of the axon? It reaches threshold because as you increase positive charges here, you bring this towards zero voltage because the difference starts getting decreased. Therefore, you reach threshold, these gates open, and therefore you propagate the nerve impulse down the length of the axon. I have a question for you. Let's look right here. The sodium is going to diffuse this way, it's going to diffuse this way. Diffusion is diffusion. It doesn't have direction. Why does the impulse then only travel this direction and not this direction? Well, it can go either way because it diffuses either way. Why does the impulse, remember those negative charges, why does that only travel that direction? Why does it only travel this direction and not that direction?
To make it equal to zero?
Sorry?
To make it equal to zero?
No? No, you learned this about the last lecture, the last mini lecture I gave you, last topic. What state is this part of the cell in right now? Refractory. This is refractory, isn't it? Can a nerve impulse occur if it's in refractory? No, it cannot. Therefore, it can only go that direction. Now, with that said, if here's your neuron or your axon, and it's a polarized state, if you initiate a nerve impulse right here, it will indeed travel both directions. Because sodium will diffuse this way, won't it? As well as that way. If it diffuses this way, what happens to the membrane potential here? It gets close to the threshold. So it can diffuse either way. But when you, yes?
I thought on an axon it can only flow one way.
In a normal impulse, it does. What I'm saying is you can, if you get an axon that's resting, you can apply a voltage here, and the impulse will go both directions.
Okay, but what will happen if it gets to the cell body? Will it
It stopped.
just stop?
Yeah. I'm just saying, physiologically, it can go both directions. The reason it does not, what's the swollen portion of the axon next to cell body called? Axon hillock. What is this axon hillock oftentimes called? Anatomically, this region here, anatomically is called the axon hillock. Physiologically, it's called the trigger zone. Because the first location of the cell that will reach threshold is going to be right here. Not here, not here, not really even here, but here. So this region here is called the trigger zone, because that's the first place that will reach threshold. That's why the impulse will only travel one direction. In a normal healthy cell without,
Where's the axon terminal?
right here. So what we'll do in the next topic is going to look at how we get the first threshold to occur here. And also how do we make this happen faster or make it happen slower. Because once you learn this, then you'll understand the role of synaptic physiology and how nerve cells integrate with each other. Okay. Questions on nerve impulse propagation. Again, that is for a non-myelinated nerve, which means what? No myelin sheath, no Schwann cell. That's correct. A myelinated works a bit differently. Okay.